Hello, everyone. So, today we are going to discuss and interpret the results of our research study, which aims at finding a suitable waste management system for the disposal of organic waste in Kabul city, Afghanistan. Now, both of our solutions were evaluated based on a set of well defined criteria. And the first solution that we're going to talk about is the usage of a geographical information system, the GIS, to optimally locate a landfill site. Based on efficacy, now when it comes to waste management, optimization is very crucial. And since the GIS adopts route optimization, meaning it selects the best route to transport organic waste to the landfill site, which reduces time and is proved to be therefore very efficient, which means that our first solution is capable to handle and manage huge amounts of organic waste that is generated daily in our community. The second criterion is cost efficiency. Now, the GIS, the purchase of the GIS's software and hardware systems range from $500 to $800,000. $500 to $800,000, yes. And in addition to the maintenance cost to ensure the proper functioning of both of these systems that were purchased in the first place, this adds to the costs about $200 to $400,000. Now, it is true that the prices may be very viewed as huge and large. However, in the long term, the GIS is going to remain for generations to come. So it is proven to be a very good investment. And with the proper funding system for this solution, we are going to be able to implement the GIS easily, and it's going to help us immensely in this community. So basically what I'm trying to say is that costs, the advantages that you're going to get, the benefits that we're going to get from the GIS outweigh the costs that are going to be inflicted on the community to purchase, to pay them, basically. Now, the third criterion is environmental sustainability, and environmental sustainability as well as safety, which is the last criterion that I want to talk about in this solution. Basically, they are closely related because they both have something with the fact that the GIS adopts a multi-criteria method. And one of the most known multi-criteria method is AHP. It's analytic hierarchy process, and it basically consists of a method that involves a set of criteria that is defined by the decision makers, such as figures of authority in Afghanistan, environmentalists, experts in certain fields of waste management, that all can be involved in this process to basically define their own criteria and give weights to them, to just basically to prioritize one criteria with the other. The one that has a higher weight is the one that is prioritized over the ones that have smaller weights. Other than that, because the GIS adopts this analytic hierarchy process, this means that one of the criteria that we can include is to maximize the relative distance from the residential areas to the landfill site, because it is very well known that a landfill site basically has a lot of greenhouse gas emissions, and so it may affect the health of the citizens that are living in the vicinity of the landfill site. So the fact that we can maximize this relative distance between the landfill site and the residential areas minimizes the negative impacts this landfill site might have on the citizens' health. Now, environmental sustainability goes by the same way, is that the GIS is also going to basically consider environmental factors that are very important to help and minimize the negative effects on the surrounding environment. So the GIS also has spatial characteristics which are very important. So the combination of the spatial characteristics that are inside the GIS and the adoption of the multi-criteria method, basically they balance competing environmental and socioeconomic factors, and to provide the optimal site for a landfill location. Now, the second solution is it involves basically installing a composting facility where aerobic composting can be performed. The first criterion that we talked about in our first solution is efficacy. Now, the second solution, based on its efficacy, this area needed more study because it has not yet been proven that aerobic composting can actually handle huge amounts of organic waste that is produced daily. Other than that, the safety and environmental sustainability here are also very related to one another, because aerobic composting is proven to be very eco-friendly. It reduces emissions of methane, which is a greenhouse gas, which in return might affect the health of the citizens near the composting facility. So it's relatively safe, right? Because it reduces these gas emissions, so it's not going to affect the citizens' health. And it is also environmentally stable because it adds nutrients to the soil. It has also been proven that the N2O gas that is produced by open burning organic waste is 300 times worse than when aerobic composting is performed. Now, the last criterion that we also considered in our study is cost efficiency. And there's no doubt that the costs that are involved in our second solution, they require the purchase of many equipment, the construction of the facility. But as we said in our first solution, with the proper funding system, we are going to be able to implement it very easily, and on the long term, it's gonna be a good investment, and it's gonna help our community. So what I'm trying to say, it's worth taking the risk of investing in such solutions to help and aid this community. Now, I also want to add one of the limitations that we had in our research study. One of the limitations is that basically the method that we used to collect data was primarily based on a literature review. So the analysis of the data that is found in scholarly articles and popular sources as well. So we didn't have that access to figure of authorities, to authority figures, in Afghanistan, to environmentalists and citizens, which adds a sense of miscommunication to our study, because it might lead us to failing to consider very important details that we need to take into account to see whether or not these two solutions are actually feasible in our community. As a recommendation, finally, I want to say that based on the evaluation that we had and the interpretation of our results, it can be shown that the GIS, the first solution, the usage of the GIS to locate a landfill site is preferred to aerobic composting, because aerobic composting is not as efficient as the first solution. Maybe if we could use a method that is known as windrow method, and it's used for large-scale composting, and it involves taking organic waste and forming long piles, rows of piles that are called windrows. It can help us in making this solution more efficient, but of course, as a result, it's going to add to the costs of the solution as well. So I also want to add one last thing, is that we can also use the GIS because it has a wide range of uses, and it has a high ability to analyze spatial data. We can also use it in order to locate the composting facility that we want to construct, so that it's also an improvement to our second solution. And thank you for watching.